Now, electric field due to line charge distribution. In 3 dimension, a line charge L is placed with charge Q and a unit charge Q0 is placed at P, and this point is A. Electric field. Now in 3 dimension in vector, we know OA vector plus AP vector is equal to OP vector. AP vector is equal to OP vector minus OA vector. This is equal to OP is equal to R dash vector minus R vector. And line charge density, this lambda is equal to Q upon L, and Q is equal to lambda L. Now electric field, first we take force is equal to 1 upon 4 pi epsilon naught Q into Q naught upon R square, and electric field E is equal to Q naught into E. Electric field E is equal to Q naught into force 1 upon 4 pi epsilon naught Q into Q naught upon R square. This Q naught will cancel. Now electric field is equal to 1 upon 4 pi epsilon naught Q upon R square. Now in 3 dimension, now we can write down electric field E is equal to 1 upon 4 pi epsilon naught, and now put down lambda into L upon R square. This surface linear charge density is equal to Q upon L. Now in 3 dimension vector, we can represent 1 upon 4 pi epsilon naught and lambda L upon R vector minus R whole modulus cube into R vector minus R vector. Now this is a linear charge density. Now I want to find out surface charge density. Surface charge density. In case of surface charge density, we take a sheet whose area is A and a positive charge Q is given to it. Now, surface charge density sigma is equal to charge upon area, and this Q is equal to sigma into area. Now in this case, we know electric field is equal to Q naught F, and F is equal to 1 upon 4 pi epsilon naught Q into Q naught upon R square, and electric field E is equal to Q naught 1 upon 4 pi epsilon naught Q into Q naught upon R square. This Q naught will cancel. Now, electric field E is equal to 1 upon 4 pi epsilon naught Q upon R square. In vector, we can write down electric field E is equal to 1 upon 4 pi epsilon naught. In place of Q, we write down sigma into A. Sigma is surface charge density, and here we write down vector R dash vector R vector cube into R vector minus R vector. Now we take volume charge density. Volume charge density. In this place we will change a 3-dimension piece, a cuboid, is placed at A and Q charge is given to it. His volume is V. Rest is same, and this is Q naught charge. Now sigma rho is equal to charge upon volume, yani volume charge density, and Q is equal to rho into V. We know electric field E is equal to Q naught into E, Q naught into F, and electric force is equal to 1 upon 4 pi epsilon naught Q into Q naught upon R square. Now electric field, same thing as before. Electric field is equal to 1 upon 4 pi epsilon naught. Here we place a unit charge Q naught, and this Q into Q naught upon R square. This Q naught will cancel. Then electric field E is equal to 1 upon 4 pi epsilon naught Q upon R square. Now we can put this one. Electric field E is equal to 1 upon 4 pi epsilon naught. In place of Q, we will put this rho into V. Rho volume charge density upon R square. Now similarly, in vector we can write down this is equal to, arrow shows vector 1 upon 4 pi epsilon naught rho V, and in this case we write this distance R vector minus R vector whole cube into R vector minus R vector. This is volume, charge density and electric field when a cuboid is placed at this and unit charge is at this.